Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, let's take a look at a very interesting and very useful AI DevOps project, AI Kubernetes Upgrader. Now by looking at the name, I'm sure you must have guessed it. We will use AI. So basically we will create an AI tool in this project which will help DevOps engineers with Kubernetes upgrades. Now why is this a useful project? Let me ask you a simple question. Why do you want to use AI? Or why your organization is pushing you towards using AI? The simple answer is to automate the manual activities or automate an activity that you do time and over again. Now, Kubernetes upgrades are one such activity. Every 3 months, Kubernetes comes up with a new minor version. Let's say the current version is 1.34. Kubernetes comes up with 1.35 in the next quarter. On top of that, there are sub minor releases, which is also called Z stream releases. Like, let's say if the current version of Kubernetes is 1.35.6, just as an example. If there is a issue with Kubernetes, or if the Kubernetes maintainers have fixed the bugs, or let's say there is a vulnerability with Kubernetes, instantly you see 1.35.7. And this keeps happening. So every 3 months, it's a regular activity for DevOps engineers to upgrade the minor version of Kubernetes. That is, let's say from 1.34 to 1.35. And in between, again, it's a regular activity to upgrade the sub-minor versions, which can be 10, 12, or you never know. It depends on the bugs. It depends on the critical vulnerabilities. So this is a super tedious activity for DevOps engineers, especially the ones who are managing their Kubernetes clusters. A lot of companies still do this. They manage their own Kubernetes clusters. They don't go for EKS, AKS, or other things. And even on EKS, some companies they take care of their upgrades themselves. So now the question is, because this is a super tedious activity, why can't you use this AI Kubernetes upgrader within your organization? Or why can't you build something like this of your own? Exactly this is what you need at the moment, especially if you're taking care of your Kubernetes cluster upgrades. And if you're planning to get into DevOps, like maybe a fresher or from a different stream, you can use this project. You can show this in your resume, on your GitHub, on your LinkedIn, and you can showcase this as your AI DevOps skill. Perfect. Now I hope the problem statement is clear. Why are we doing this AI Kubernetes upgrader? Now let's deep dive little more and first try to understand, like before we build this AI Kubernetes upgrader, what level of manual activity is involved? Okay, Abhishek, like we upgrade from minor versions, we upgrade the sub minor versions, but what is the role of DevOps engineer while upgrading these things? So you can understand the scope of this project better. So basically, every time, let's say there is a minor version upgrade, 1.34 to 1.35, DevOps engineers perform the following things. First, they look at the release notes. So release notes are important because they give you a clear picture. Kubernetes release team writes this. They provide the information what changed within the release, how many features are added, how many bugs are fixed, and what is the scope of those features or bugs. And then DevOps engineers also make sure they have backup because let's say something goes wrong, they need to fall back. So they have the backup of the existing cluster or cluster resources, any fallback mechanism or the failover mechanism. Then they verify the cluster health before upgrading. Especially in lower environments, this is important, like the dev environment, staging environment, because these clusters are always messed up. When you give your dev environment to your developers, they might deploy different resources on it. They might uh, install different CRDs on it. So there is a huge possibility that the cluster health is messed up. So DevOps engineers also look at the cluster health, different APIs, and only if the cluster health is right, they proceed with the upgrades. And then they start with the control plane upgrade. So these becomes the prerequisites. And then The actual work starts with the control plane upgrade, which is kind of simple when compared to the data plane upgrade. So in the control plane upgrade, basically they look at different control plane components and see how to upgrade them. Like what are the different components that are involved in this. Then they upgrade the worker node once at a time. Right? There can be 6 node cluster or 3 node cluster. So what DevOps engineers usually do, they pick up one worker node, complete the upgrade, and then move to the other worker node. Just if you want to understand this in detail, basically they start with cordoning a node, right? Basically they make a particular node unschedulable. Let's say they want to upgrade the first node out of 6. They first cordon this, they make it unschedulable, so no new pods get into this. And then they drain the node. So the existing pods, they move to the other 5 nodes. And once they ensure these steps are done, then they start with upgrading the Kubernetes components on the data plane, like kubelet or kubeproxy. Then they reboot and finally uncordon and verify if the new version is added. Of course, then they attach the worker node to the control plane. So many steps are involved, and these are very sensitive steps. And finally, verify the cluster once the control plane is upgraded, data plane is upgraded, sometimes the cluster add-ons like core DNS and all. Finally, they validate the upgrade, and in some cases, let's say there are some sensitive environments, DevOps engineers also monitor the cluster upgrade, maybe for 1 week or maybe for 2 weeks. They see if the new cluster upgrade is not creating any issues for the organization. Now, imagine how much time this would take. Let me tell you, this can take 2 to 3 days as well. At times, when the worker nodes are more, when the environment is sensitive, this can go up to 2 to 3 days as well. Now, after 2 to 3 days of effort, if any of these checks are not verified well, right? Maybe when they are looking at the cluster health, they did not look at the cluster health well. The 2 to 3 days of effort is wasted. Instead, we can get this done by AI. Now, there is a fine line here. What you need to understand, I'm not building a project and I'm also not recommending you to build a project that would use AI to upgrade the Kubernetes cluster. No, I'm not saying to build this. I'm saying use AI to see the feasibility or AI that can assist you and tell you, yes, this upgrade is possible. I'm 80% confident that it would not mess up your cluster after the upgrade. This is important, right? Once you have the feasibility, yeah, you can go ahead and upgrade the cluster even if it takes 2 days of time. After 2 days, you have a new version and your effort is not wasted. Now you might say, but Abhishek, then the valid name for the project is AI Kubernetes Upgrade Validator. Yeah, it's fine. If you want to call it, you can call that as well. Or if you want to combine both of these capabilities in the future, once you use this feasibility or validator for, let's say, 6 months, you're confident about it, then you want to also add the upgrade capability, you can also add that. But initially, just start with this because trusting AI for upgrades at this moment is not a good idea. Nice. So how are you going to build this project? I'll first start with the toolset. We'll keep it very simple, especially for this project. I'll use Python for building the required CLI. We don't need user interface for this project. CLI is good enough. And then coming to the models, I'll go with OpenAI API. But if your organization is very strict about the data, you can also use Olama with local model integration. But for this, you need GPU compute. Maybe you can spin up a machine on AWS, Azure, or you need something like a DJX Spark. That's it. We will only use these two things in the project and we will be able to achieve this. Coming to the Kubernetes cluster, I'll use a local Kubernetes cluster, the kind cluster, because to spin up an EKS cluster and verify the project on the EKS cluster, it takes a lot of money. Instead, we'll go with kind setup. Let me also talk about the architecture so that you can understand better. Now, what happens once we build this project? User gets to access the Python CLI, the tool that we build, What this tool does, it takes input from the user. What version are they planning to upgrade? Let's say they provide the version as 1.35. Now CLI makes use of kubeconfig. Abhishek, how to make this more sensitive? Within your organization, let's say if you're using SSO, you can make use of tools like auth0. So you don't have to use kubeconfig. But this is a good first start. CLI makes use of kubeconfig. It gets the current state of the cluster, like what is the version of the cluster, what are the APIs in the cluster, and all that information. Now, in the meanwhile, CLI makes use of OpenAI to fetch release notes of the Kubernetes cluster. I mean, the release notes of the new Kubernetes version. And then this state information, whatever CLI gathers, let's say the different CRDs on the cluster or the different APIs on the cluster, how many nodes on the cluster, all that information, this will pass the information to the OpenAI. Now, using the release notes and the current state of the cluster, OpenAI performs the validation. And once the validation is complete, it will give a detailed summary back to the user. This is the architecture that we are going to follow. I'll repeat this one more time because architecture is the critical piece. And then we will head to the implementation. So user interacts with the CLI component that we are going to build. We will make use of Python to create this CLI utility. CLI takes input, the version, the target Kubernetes version. Let's say if it is 1.35, CLI makes use of kubeconfig. It gets the current state of the cluster, everything that it needs using kubeconfig, like the kubectl commands. In the meanwhile, CLI makes use of OpenAI. It gets the release notes of the new Kubernetes version. Then using this release notes and the current state of cluster, OpenAI. So basically in the CLI, we will make an API call to the OpenAI API. We will go with a particular model version. It performs the validation, and post validation, it will share the steps like the detailed summary. If the validation will be, if the upgrade can be feasible, not feasible, what is the level of confidence, a detailed summary to the user. Perfect. So now you understood the tools, you understood the architecture. Let's head to the implementation part. Now for the implementation, we will use GitHub Copilot with Visual Studio Code. But the big question is, what prompt are you going to provide? It has to create the Python backend or the CLI for you. It has to set up OpenAI integration. You are not going to write all of this. The prompt is going to be huge because this is a very, very critical activity. There are so many things the CLI application has to take care of. So what I've done, I've created this prompt for you, and I've also put this prompt in the GitHub repository. So now I'll take time to go through the prompt. This is a very, very important thing. See very carefully how I created this prompt and how many sections are included in the prompt so that in almost one go, the GitHub Copilot can build that CLI application for us. First, I started with the objective saying you are acting as a senior Kubernetes platform engineer, or you can say senior Kubernetes DevOps engineer, performing a comprehensive upgrade readiness review. Not the upgrade, but the readiness review of the upgrade. Your task is to determine whether Kubernetes cluster can be safely upgraded or not. Source version and the target version. Then I'm saying the analysis must be exhaustive, evidence-based, and conservative. So that basically I'm saying AI agent, don't overthink. Your primary goal, anything that can break during the or after the cluster upgrade, unsupported APIs, controller incompatibilities. Basically, let's say you're using Istio. Maybe post upgrade, the version of the Istio that you're using is not compatible because of anything, or it might break. CRD incompatibilities, admission, webhook risks, operator risks, runtime risks, networking risks, storage, security, workload, node upgrade risks, and control plane risks. If you feel you take care of anything else within your organization, just add that point to it. The prompt is already curated. You just have to modify something in the prompt. Do not assume. This is something that you have to tell AI every time so that it does not hallucinate and overthink beyond your requirement. Now the assessment requirements. Okay, I've provided what assessment requirements it has to take care of. Then I have provided the step-by-step integration. For example, gather cluster information. But Abhishek, why do I have to give this kubectl commands? AI knows what kubectl commands it has to take care of, right? AI knows what information that it has to fetch from the cluster. The problem is that if you don't give this information, it will go crazy. It will perform n number of kubectl commands, and it might charge tokens for you, your compute power, which you definitely don't want to happen. So that's why keep the kubectl commands. If you're already performing Kubernetes cluster upgrades, you would have that document somewhere in the Confluence. What steps do you usually take care of? Put those kubectl commands here. That's it. So that AI does not overthink. In the step two, I'm saying inventory resources, what it has to collect. Then the install CRDs, what CRDs it has to collect. Controllers, what controllers it has to collect. Now this differs from organization to organization. I put the popular controllers here. If you want, you can also list the controller within your organization. Or you can tell AI, use the kubectl get CRD and get all the CRDs so that it knows the controllers. Analyze Kubernetes release notes. As I told, this is something that the OpenAI integration is going to take care of within the Python CLI. API removal analysis. Then I provided the steps. Take care of deprecated AI analysis, CRD compatibility analysis. What I actually did, I have a notes of Kubernetes upgrades. Like when I am performing a Kubernetes upgrade, I have detailed notes what I usually take care of. That's in the GitHub MD file. I provided that MD file. I, kind of modified it and I put them in the organized format in the prompt. So that's why the prompt is very, very detailed. On top of that, if you go to the, towards the end of the prompt, I'm also saying how the output should look like. So I'm saying this is what I have to say. Control plane, pass, good, warning, nodes, APIs, CRDs, controllers, networking, storage, security, and finally the failure analysis. So I don't have to, you know, worry about is networking good, is controller good. For each and every component, it is going to provide me with pass or fail. Perfect. So take some time, go through the prompt. It is a very, very huge prompt. I kind of intentionally made it very huge so that the application is built in one single go. Now we will take the raw format, right? Copy this entire thing, put this in GitHub Copilot. If you want, you can go with the auto mode or you can select a specific one. Claude Sonnet 4.6 is good enough for this. Okay. So all the prompt is here and I'll go ahead, click on the start. Now this would probably take 10 minutes or 15 minutes for the entire CLI to be built. Once we have the CLI, we will take a look at the next step. Nice. So we have the output ready. So I just created main.py file. I was going through it. So Python main.py, you just have to provide the source version, target version. And if you want to see the output in a report, you can also provide -o report.md. And before that, you have to execute the dependencies. Let's see what all did it do. On top of that, yeah, it created a .env file where you can store your OpenAI secret or your Olama integration related things. In the main.py file, again, I was going through it. It was fairly simple. So list of dependencies, then list of kubectl commands that it is going to execute, whatever we provided in the prompt. Then it is going to execute these kubectl commands, the CLI. It is going to gather the cluster data using the CLI commands. Then it is going to use OpenAI. So this is the prompt that it built. It shares the cluster state. It also gets the release nodes information. And here it is performing the analysis. And finally, it is sharing the output with us. So all as expected, at least looking at the source code, looking at the instructions, I feel this should work. But you never know. So we'll go back to the terminal. First thing that we'll do, create a Kubernetes cluster. and test this out. So using kind, let's create a little old Kubernetes version, right? So that we can upgrade it. Kind create cluster hyphen hyphen name. Let me call this as K8's 1.34. Okay, I'll spin up 1.34 version. How do I do that? I can just say hyphen hyphen image kind set slash node colon 1.34.0. I hope the command is right. Okay, so it is spinning up 1.34 Kubernetes version for us. All good. It should spin up the cluster in less than 1 to 2 minutes for us. Because it does not have the node image, probably it would pull the image. Error response from daemon, pull access denied for kind node set. Let's see. Yeah, there you go. So we have the cluster ready. So basically there was a typo. I just changed it to kindest and also changed the version from 1.340 to 1.343. Looks like this image does not exist. Cool. So we have the kind cluster ready now. Let's clear the screen now. I'll switch to the folder. So this is in the downloads folder. The project is AI Kubernetes Upgrader. Perfect. We will start with creating a virtual environment because whenever you work with Python, it is recommended to create virtual environment so that dependencies does not mess your system. So Python 3 hyphen m venv. Let me call this as .venv. And let's source the virtual environment. Source .venv slash bin activate. Let's first install the dependencies. Pip install hyphen r requirements.txt. Okay. So this is pulling all the dependencies that we need to run the main.py. This will also have the OpenAI dependency. And just to tell you, I've already updated OpenAI.env. The .env file with OpenAI API key. And this is the model that we are going to use, GPT-4o, because this consumes less number of tokens. Okay. So now let's try Python 3 hyphen m, my bad, Python 3 main.py. Source version, I'll call the source version as 1.34, target version 1.35, and hyphen o report.md. Now it knows which Kubernetes cluster it has to upgrade because it is using kubeconfig and kubectl. So it is connected to the Kubernetes cluster that we just created. And there is nothing in the cluster. So let's see what does it say, if the upgrade is feasible or not. And also let's see how confident it would be about the upgrade. Okay, so it is collecting all the information very fast. It connected and collected the cluster data. Kubernetes upgrade feasibility, streaming assessment from GPT-4o. Okay, it is performing all the assessment you can see here. Step 1, step 2, step 3. This is what you would have done manually. Now AI is doing it for you. Okay, it performed all the assessment. Looks like we are almost ready. Yeah, and it stored the assessment here. Let's copy this file and read it. I'll open the file. What does it say? Or let's open this in the MD file, Vim file format. Vim report.md. Okay, generated Kubernetes upgrade AI. This is a model that it used. Assessment for 1.34 to 35. Step 1, gathered the cluster information. Let's go to the bottom. Cool, you can see here, source version, target version, readiness score is 85 by 100. That means, AI cannot give you 100% readiness. When you see 85, that means your cluster is ready to upgrade. Confidence is 70%. So that itself says it is 70% confident. If you want to go high, use higher reasoning or higher thinking model, maybe like Claude Opus 4.8, or if you're using OpenAI, maybe you can go with GPT 5.5 or above model. But yeah, readiness score is 85 and confidence is 70. It says high risk. None of the high risks are detected. So you are perfectly good with the cluster upgrade. Now you can go and manually perform the cluster upgrade. Or if you want, you can share this report with your management saying that this is the analysis we have performed. Now everything looks good. Control plane status looks good. Node status looks good. CRD status is passed. So we are proceeding with the upgrade. I shared the prompt in the GitHub repository. You will find the link in the description. Go ahead, try this cool project at your end. It would hardly charge you less than $1. If you have access to GitHub Copilot, that is more than enough. Or any agent. It can be Cursor, Claude. You just need access to it and less than $1 for your OpenAI integration. Or if you have Olama, you can do it locally as well. I hope you found this project useful. This way we are creating a lot of AI DevOps projects on the channel for absolutely free of the cost. You can find AI DevOps project playlist on the channel. See you all in the next video. Take care.